Okay guys, press pause please. And just turn around and let's mark question 4 please. Okay, right. So, question 4. So the first thing I would do in graph questions is highlight the different graphs, right? So it says in the question, you've got a hyperbola which is f of x is 5 over x minus p plus q. Okay, so the first thing I would do, where is my hyperbola? It's there. Okay, and it's over here, right? And there are the asymptotes of the hyperbola, right? And then you've got a log graph, okay, which is over here. So it's very easy when you've got more than one graph on a set of axes, then you start mixing up your graphs. Okay, so I would do that first. I would also then check that everything that is written there is given on your graph, right? So first of all, they say x is equal to 2 is the asymptote, the vertical asymptote, okay? And they tell me y is equal to 1, passes through C, so at C y is 1, okay? And that it's an asymptote as well for the hyperbola. So that's how I start the question. Okay, before I do, look at any question. Okay, that's the first thing I would do. Okay, the first question says, if h of x is equal to x plus t is an axial symmetry for the hyperbola, then determine the value of t. So what your key idea is with axial symmetries of the hyperbola? Where do they always pass through? They always pass through the intersection of the asymptotes. There are always two. Okay, one has a gradient of -1 and the other has a gradient of 1. So if you're not listening, it's fine, but just don't talk, please. Okay, so this one has a gradient of what? If that's the equation, the gradient must be 1, right? So we're looking at, we're looking for that asymptote over here, right? I mean not asymptote, axial symmetry, right? And we know that that is y is equal to x plus t, right? So the question is really saying find the equation, but they've given you step 1. Sometimes they don't give you step 1. They've given us that the gradient. If they had said the one with a positive gradient, you would have just said m is equal to 1. Okay, you've got to know that fact. Okay, axial symmetries of hyperbola either have a gradient of 1 or a gradient of -1. Okay, you've got to remember that. And they pass through where the asymptotes meet. So what is this point over here? What's the coordinates of that point? X is 2 and y is 1. So go through the point 2, 1 and it's got a gradient of 1. The question is really saying to you, go find the equation of this thing over here. So we know that for h, y is equal to x plus t. So what we're simply going to do to solve for t? Sub in a point that it goes through, right? So I'm going to sub in 2, 1, and I get 1 is equal to 2 plus t. So -1 is equal to t. Okay? And that's the question answer. Okay. I would on the graph now go right here, y is equal to x minus 1. Who knows? Maybe I need it, maybe I don't. I like to pull everything on a graph interpretation question as soon as I work it out. Everyone okay with that? Okay. Good? Okay. Right, the next question, sorry, can I see someone's question there? Says, calculate the x coordinate. I'm going to do them over here because I'm not going to keep going back to the diagram. What does that question be? For B, they want the x coordinate of point C. So here is point C over here. Okay. What do we know about C? What's the y coordinate? 1, right? Then to find the x coordinate of this graph, I need to know the equation of that graph. Do I know the equation of the green graph? The green graph is log 3x, right? Okay, this is graph G over here. G of x is equal to log 3x is the green graph. So, nearly half of graph interpretation questions are you're given one coordinate, you're given the equation, you've got to find the other. Okay, so we know that y is equal to 1, and we know that it's on graph G, so y is equal to log base 3x. So what are we going to do simply in order to solve for x? Combine those two things, sub in y is equal to 1 and y is equal to log base 3 of x. How do you solve an exponential equation? You write it in log form. How do you solve a log equation? You write it in exponential form. What's the key thing? Your base stays your base, right? So if I write this in the exponential form, it becomes 3 to the what? 3 to the 1 is equal to x. Okay, therefore x is equal to 3. Quite honestly, if you recognize, remember that log, two things which are worth remembering with logs, if those two things are the same, it's always equal to 1, right? Okay, so if to get 1, it must be the same. If you just wrote 3 as the answer, I'd give it to you. Okay, probably. Okay, so x is equal to 3. Okay, so that, what was the question? Always check we've answered the question. How did they ask the question? Calculate the x coordinates of C. That's what it doesn't say write down the coordinates, right? Yeah. So C is a point, fill it on your graph. Once you've got something, put it on the equation. So C is 3, 1. Are we happy with that? Yes. Right. The next question said what? Okay, don't worry. Find the length of AB. Okay, that was question C, eh? Okay. Yes. So, find the length of AB. Okay, so you just got to say to yourself, what do I know about A and B? So find length AB. Where is AB? AB is over here. They are what? What's happening at A and B? Intercepts. X intercepts, right? And I don't know either of those two things at this stage, right? Okay, so at B. So do you believe if I've got the coordinates of A and B, then I've got the distance AB? Okay, so let's look at B first, because that's easy. What do I know about B? What coordinate do I know at B? The y coordinate. Ask yourself two questions. What coordinate do I know? What graph does it lie on? What graph does it lie on? It lies on the graph of y is equal to log base 3 of x. If you wrote x is equal to 1, I'll give you the mark because we should know that log, no matter what your base, log base 1 is always naught. Okay, but if you want to write it in exponential form, what's it going to become? Base 3 to the 0 is equal to x. So therefore, x is equal to 1. So this is now the point we know that at B, that's the point 1, 0. Are we happy with that? Okay. Now what do I need? I need to find the x coordinates of A. Okay? So at A, we know that y is 0. And what's the equation? Well, they didn't give us the equation. They said to us what? They said the equation is of graph f, the red graph, is y is equal to 5 over x minus p plus q. But can we get the equation? Yes, because we know the asymptotes. Okay? So it's going to be what? To me, y is equal to 5 over x minus 2 plus 1. Okay, so now I know, what do we always ask ourselves? What coordinate do I know? What graph does it lie on? So it lies on that graph, and we know y is equal to 0. We combine those two things, okay, and we get, to combine those two things, we get 0 is equal to 5 over x minus 2 plus 1. Are we happy with that? Yeah? This is all got to do with point A. Okay? What's the easiest way to do this? First move the 1 across, right? So negative 1 is equal to 5 over x minus 2. Then what? Times both sides by x minus 2. Okay, so therefore negative 1 times x minus 2 is 5. Are we happy with that? Now I distribute the negative 1 into the brackets. And I get negative x plus 2 is equal to 5. So negative x is equal to 3. Divide by negative, and x is negative 3. What have you just worked out? The x coordinate of A. So go fill that in the diagram, and then go right down. You know the x coordinate of A is negative 3. You know the x coordinate of B is 1. So then go right down the distance AB. So at this point A, then we have x is negative 3. Okay, so that's negative 3, 0. B is the point 1, 0. So what's the distance AB? AB is 3 plus 1. So AB is equal to 4 units. Half of graph interpretation is saying to yourself, what equation does the point lie on? What coordinate do you know? Combine the two things together. We good? So right hypothesis. Right. Good job, good job. Right, Clyde is here, right? You marking, Clyde? Yes. No, you're not.
I always go back to ours.
I'll do what? Right, okay, so now, next question was what? So we've done the length of AB. Find the equation of g to the negative 1 of x in terms, okay. So, what was g of x? G of x was? So g of x was y is equal to log base 3 of x, right? Okay, with everything else, okay, when finding inverse, what do? Swap the x and y around, and then go get y on its own. But we don't do it with log and exponential graphs, it's a waste of time. What do I have to remember? What's the inverse of a log graph? Exponential with the same base. What's the inverse of an exponential? The log with the same base. Everything else, we swap x and y around and go get y on its own, right? So g of x is log 3 of x. Okay, then g to the negative 1 of x, the inverse, is equal to what? You don't have to show any working. What's the inverse of a log graph? Okay, the exponential with the same base. Was that the question? And I say write it in the form y is equal to. Follow the instructions, so the final answer should be y is equal to 3 to the x. That is your answer for question C. You all good with that? Still seems to be cute.
Yep. Well, there's still people keeping absent.
Okay. Are we happy with that? They're getting annoyed.
Well, no, our teacher's annoyed.
Okay, right.
Because we never know they, yeah.
Right. Okay. Are they part-timers?
Experience, sorry.
Right, okay, right. So we now will see the short series. Give her a round of applause. So, 1, 2, 3. Right. Okay, right. So E. Okay. Okay, what's an item there? Siobhan? What's an item?
84.
Yeah. Right. Okay, then E said what? Okay, which values of x is f of x times g of x less than 0? So that's that would be, even though this is section A, that would be classified as a section B type question. So the question says, when is, what does the question, remember question E?
Yes.
Okay, so for E, it says, for which values of x is f of x times g of x less than 0 or less than equal to?
Less than.
Less than 0. So what does that mean? Okay, it means when are the y coordinates of f times the y coordinates of g negative, right? Less than 0 is negative. To get negative answers, when you times two things together, what has to happen? One has to be positive, and the other has to be negative, or it could be the other way around, right? Or we could have negative and then positive, right? Okay, we are going to use the graphs to do that. We are not going to set up some bizarre inequality. It's not algebraic. Okay. So we've got to go and get a piece of paper, get your information sheet in the exam, and work from left to right. So if you take this, so I cover up the graph, right? Okay. So first of all, does this log graph exist to the left of 0? No, its domain is, remember you can only put positive values into a log graph, right?
Yes.
So, I can't even talk about, okay, graph G, which is the green graph, sorry. The green graph doesn't exist to the left of 0. You with me? So it's meaningless to start talking about f of x times g of x, right? So where does this sum start? Okay, it starts at there, right? So I cover that up, right? Immediately after 0, what are the y coordinates of the green and the red? They're both what? Negative, do you agree? They're both, if I look at this graph, the green graph and the red graph are still both below the x-axis, right?
Yes.
So if I times them together, what's f of x times g of x going to be? A negative times a negative, which is a positive. Do we want that?
No.
No, we want a negative, right? At B, the 1 crosses over. Do you agree? Okay, at B it crosses over. Okay. Can I include B? No, because if I times them together, the y coordinates will be 0, and it says it has to be less than 0. So after B, the green graph becomes positive, and the red graph is still negative, right? Do you agree with that?
Yes.
Okay, if I put a piece of paper there, the green graph after B is positive, and the red one is negative. You see that? Okay, is that what I want? Yes. So the question says, when does it happen? So the first area where it happens, so I'm just going to enlarge it, is over here. They're both at B, after B to the right of B, this becomes positive and that's negative, right? So if you want, draw the answer on your number line. I'm going to do it here in blue. Okay? So there's, after B, I get what I want, right? It carries on till where? Till 2. Remember, this other graph doesn't exist at the asymptote, right? So between 1 and 2, both open dots, that's your first region, where the y coordinates of the green times the y coordinates of the red are negative. Capish? The answer. So my first region, the answer for E, we're going to say x is an element of, between where and where? What are the x coordinates there? Between 1 and 2, round brackets, right? Sorry, that should be positive ones. Are you happy with that region? Or you could write arrows to the left. Okay, either left. Then what happens? Now I keep going to the right. Okay, after 2, what's happening? The green graph is what? What the y coordinates of the green graph? Positive. It's above the x-axis. And the red one is? Positive. Is that what I want? A positive times a positive? No. Keep positive, positive. Do they ever swap over again? No. Okay, so there's my answer. X is an element of 1, 2, or x lies between 1 and 2. Does that make sense? Is there anything else to question for? No. All right, guys. Keep going.
Let me see. You know what to do. Just read the question.
Excuse me, people watching this. There's a lot of aggression in this class. Okay, right. Right. Okay. Sharing. Okay.
No, because you're so cute. No, that's really no, you're so cute. No, it's me. You said your
Must I give that a clap?